My name is Giuseppe Colombo. I'm Technical Director of Milano Serravalle, Milano Tangenziali, holder of a concession agreement granted by the Italian Ministry of Infrastructure and Transport for the management of the section Milano-Serravalle-Scrivia of the E7 Milano-Genova motorway, as well as the three Milan motorway ring roads. The role includes, among other things, the responsibility for ensuring compliance with Italian technical regulation for the infrastructures under concession, the supervision of major structures, and the planning and execution of maintenance for civil and road works. Among these, one of the most significant structures is the Parchi Viaduct, located on the eastern ring of road of Milan. The Viadotto dei Parchi is a critical structure within the Milano-Serravalle motorway network and plays a key role in the region's transportation infrastructure. Originally designed by the engineer Silvano Zorzi in the 1970s, the viaduct has a continuous deck structure with span of 24 meters. The structure is made of post-tension and pre-stressed concrete. Its design features a zero-moment point positioned at 7 meters from the pier axis, realizing through a Gerber-type saddle system that ensure efficient lower distribution and structural continuity. The viaduct is composed of two parallel carriageways, each carrying a separate motorway lane, and extends nearly 3 kilometers in length, making it one of the longest and most strategically significant viaducts in the network. The structural complexity of the viaduct increased in the early 1990s when, in response to rising traffic volumes, an additional lane was added to each carriageway by widening the deck. This complexion makes the viaduct an ideal candidate for an advanced monitoring solution capable of tracking dynamics behavior, material degradation, and long-term structural performance. In fact, the structure was subject to periodic monitoring activities carried out mainly through inspection visits, which, however, cannot provide a quantitative assessment of the actual safety factor of the structure with respect to the load to which it is subjected. Finally, the inspection provides only discontinuous information on the structural behavior of the viaduct. Periodic inspection of all structures within the concession network are carried out by an external specialized company. Within our organizational structure, there is an office composite of 4 structural engineers who are responsible for summarizing the observation made and for verifying the data collected by the monitoring system. When clear signs of deterioration are observed on structures, it becomes necessary to carry out in-depth investigation campaigns and design checks, for which specialists are involved, generally from organizations external to the company. The Milano-Serravalle-Milano Tangenziali SPA motorway network includes over 450 bridges and viaducts across 187 kilometers, most of which were erected during the 1960s and later expanded in the 1990s to accommodate increasing traffic demands. Almost all major historic structures were built in reinforced concrete, either conventional or pre-stressing, and are therefore subject to superficial carbonation of the concrete and consequently to the loss of the passivating effect on the reinforcement bars. In general, environment exposure, material aging, and increasing traffic loads have pushed a degradation mechanism, increasing the risk of structural deficiencies. These aspects are exacerbated by the difficulty and in some cases the impossibility of inspecting certain parts of the structures, which nevertheless can represent elements of potential criticity, as is the case, for example, with the Gerber saddle embedded with the thickness of the deck of the Parchi Viaduct. I get in touch with KM8 in 2023 when Serravalle received European funding for the implementation of an SHM system. We were confident that collecting a large amount of data from the sensor installed in the structure will lead to significant interpretation issues if the data were not processed and compared with theoretical prediction of the structure's behavior under load. The difficulty lied from the lack, at least for some of the structure, of complete design documentation dating back to the time of construction, as well as from the possible presence of construction discrepancies or hidden imperfection within the structure components. This aspect made it difficult to theoretically assess the behavior of viaducts and bridges under the effect of applied loads. For this, K-Mate's approach, based on reverse engineering processes driven by AI algorithms that make it possible to create a true digital twin of reality, had positively impressed us. To address these concerns, Milano Serravalle Milano Tangenziali SPA equipped its most critical structures with a comprehensive network of advanced monitoring sensors and deployed the innovative WeStatic SHM platform to enhance the real-time diagnostics, improve structural assessment accuracy, and support predictive maintenance strategies. The SHM system has been installed on all main viaducts along the motorway network managed by Serravalle, covering a total of approximately 340 spans. It enables continuous verification of the consistency between the static and dynamics behavior recorded by sensor and the theoretical prediction calculated on the digital twin. In addition, the system provides a continuous assessment of the level of material utilization within the structures, thus allowing for a coincident representation of the safety factor even in the absence of emerging anomalies. Beyond improved awareness of the structural condition, the presence of a remote monitoring system allows, in accordance with Italian regulation, a reduction of the frequency of visual inspection, resulting in significant economic saving. The presence of SHM system ensures greater awareness of the actual response of infrastructure to load traveling over it. It also represents a powerful tool for documenting the condition of the structures at a given point in time and enables the recording and interpretation of any variation that may arise. Furthermore, the system ensures greater objectivity in the assessment of the onset of defect, which during visual inspections carried out by technicians often tend to be overestimated. In May 2021, several spans of the viaduct has been subjected to static loading using 6 fully loaded trucks, and each weighing approximately 30-32 tons. The load configuration was strategically designed to induce representative loading conditions that could accurately reveal the structural response. Displacement data was recorded using topographic survey methods to measure deck deflection under loading conditions. Later, the digital twin model was employed to simulate the same load conditions, integrating details such as vehicle position, tire contact pressure, and asphalt layer load distribution. The comparison between measured displacement and predicted values from the digital twin showed remarkable alignment, with the discrepancies remaining below 5%. This result confirmed the model's high fidelity and its capability to replicate the real-world structural behavior with precision.